Exercising offers a plethora of different benefits to the body, mind, and soul. Exercising is the act of engaging in a physical activity to improve overall health or physical toughness. My name is Kimmel Wadlington, and today I will be demonstrating and educating you on the technicalities of exercising. So, why do people exercise? Well, there are a couple of different reasons. For one, exercise boosts brain power. 2, movement melts away stress. 3, exercise gives you energy. 4, it is easy to find time for fitness. 5, fitness can build relationships. 6, exercise helps ward off disease. 7, fitness pumps up your heart. 8, exercise lets you eat more. 9, exercise boosts performance. And lastly, 10, weight loss. There are also has been research that has been shown that you're less likely to develop type 2 diabetes, coronary heart disease, and high blood pressure through exercising. Lifting weights, even small ones, can also help bone density in older adults. So how do muscles work exactly? Well, muscles are generated through oxygen, through a process called cellular respiration. Cellular respiration is the process in which your muscles use oxygen to produce ATP energy. So let's pretend your muscles are a car. Your cells are a car. In a functioning car, you have 2 tanks. For this specific purpose, we're going to say tank 1 has glycogen and tank 2 triglyceride. Glycogen is a fatty acid found in the body that helps store energy. It is the body's first fuel tank. Triglycerides, or fatty acids, are a secondary fuel source for the body. And protein, the infrastructure of this car, is what keeps it all together. So, and then lastly, the engine is the mitochondria, the power source. So, in a car, you drive, and then you get that little gas tank that comes up when you're about near the end of your gas mileage, and then it signals that you need more gas. However, the second tank will kick in and give you enough fuel to just go to the gas station. The infrastructure of the muscle protein is what's keeping the car together, and the mitochondria, the engine, is what's fueling the car, essentially. In the human body, the muscles are capable of including glucose from carbohydrates, acids from fatty acids, and amino acids from protein. The type of fuel that is burned for energy depends on the density and the duration of exercises. In other words, the longer you run, the more energy you will need to sustain your body. Do you ever notice that when you're exercising, you start to breathe heavier? When you begin working out, your body needs oxygen to the muscles so they will stop working. Muscles rely on 2 processes: getting blood to the muscles and extracting blood from into the muscle tissue, making the pipe bigger. Whenever you see a fire truck with a fire hose, the water is going through the fire hose quicker than it would a garden hose. And that is due just because the fire hose is bigger than a normal garden hose. As you exercise, the blood vessels in your muscles dilate and the blood flow is greater. For example, more water flows through the fire hose than through a garden hose. When you begin to exercise, oxygen is diverted from the organs to the muscles. Muscle growth comes about because of hypertrophy or hyperplasia. Hypertrophy is an increase in the muscle size due to an increase in the size of the muscle fibers. Hyperplasia is an increase in the number of muscle fibers. When you exercise, blood that would normally have gone to your organs, such as the stomach, goes and feeds your muscles. So how do the muscles get blood from the other organs exactly? Well, as your muscles begin to work, the sympathetic nervous system, comprised of the brain and the spinal cord, stimulate the nerves to the heart and blood vessels. This nervous stimulation causes the blood vessels, arteries, and veins to contract or constrict, causing vasoconstriction. Vasoconstriction reduces blood flow to the tissues. Your muscles also get the command for vasoconstriction, but the metabolic byproducts produced within the muscles override this command and cause vasodilation. Vasoconstriction is when the blood vessels which increase blood pressure, so they constrict. Vasodilation is the widening of blood vessels. Here is an example of vasoconstriction. As you can see, the pathway of the blood is smaller, and vasodilation is the total opposite. When you're exercising, your body will naturally get the signal for all of it to vasoconstrict. However, your body will override that process, the muscles will override that process, and the blood vessels fueling your muscles will vasodilate so that more blood is able to get to your muscles. Hence, vasodilation allows for more blood flow, and vasoconstriction cuts off blood. Vasoconstriction happens when the blood flow to your organs, such as your stomach and your kidneys, are pushed, and there's less blood flow because more of the blood is going to supply your muscles. And essentially, your muscles need blood and oxygen for them to operate, or they will shut down. Lastly, if you ever notice when you're exercising, your heart starts to race and your blood pressure rises. This is due to cardio output. Cardio output is a measure of the amount of blood that is pumped out of the heart per minute. In a resting heart, the cardio output is about 5 liters a minute. As you begin to exercise, sympathetic nerves stimulate the heart to beat with more force and faster. The rate can increase about 3-fold. Here's a diagram of cardio output when there is exercise and at rest. During heavy exercise, your heart is pumping more blood. However, if you notice, your organs are receiving less blood flow, and the muscle towards the end of the diagram is receiving more blood flow. For example, it is receiving 70 to 85% of blood, whereas when your heart is at rest, your organs receive more blood. So here is your intestines, duodenum, small intestines, your kidneys are receiving blood, your brain, your bones, your cells, but the muscle is receiving less. It's receiving 15 to 20%. So the blood is kind of distributed differently than when you're exercising heavily. During exercise, your body will pump 20 liters per minute throughout heavy exercise. At rest, your body will pump 0.75 liters of blood per minute. In conclusion, your body goes through a lot of different phases through exercises. I've only touched the surface of what your muscles go through and what your heart contributes and your other organs contributes to your exercise. Essentially, every single organ is affected by exercise. The benefits of exercising are limitless. Not only will you feel better, your body will thank you for it later. Now that you have seen a little of what goes on, you will understand what is happening that next time you go for a run.